Okay, so this is, it says graph the function and find values where the function is discontinuous. Okay, so for these are piecewise ones. You don't have one like this, but I'll still go over piecewise just in case. I mean, it's a good skill. Um, this is a college algebra concept. What I would do with this is maybe do another one. I don't know if we can today. We could probably do one again on the review session tomorrow. Let's see how many questions everyone has. But this is going to be lengthy because this is a whole teaching like lesson. All right. So piecewise functions are functions that come in pieces, and to graph each of them, like you don't even know which one of these graphs is here, right? You take each little piece of the domain. So we have one set is for when x is less than 2. And so, I mean, there's this one's x is less than 2, this one as well, and this one. We just need to make sure it's defining it the right way. So when x is less than 2, we have the function -4. That is just a straight horizontal line. It's like y equals -4. If you look, all of these are a horizontal line going through -4. But instead of drawing the entire line, it's restricted to when x is less than 2. How many points define a line? 2, yeah. So you can pick any point. Now, when it's saying less than 2, think about the number line. Any number that's less than 2. Just anyone. You want to put 0, 1, whatever. Just another, right? Okay. When you do that, you're going to draw your graph. I'm going to do it up here. And then you can kind of see the. So we're at -4, 1, 2, 3, 4. And it's the points I have are 0, -4. So here, let me do it in color. And 2, -4. Now, before I draw that one, what I typically do on these, like if we didn't already have a graph there, is I make a note that, see how it doesn't have an equal on there? See how there's no little equal sign? That means that this is open. In other words, you're going to have a hole in the graph. So hole. Unless for some reason it connects, sometimes one of the other pieces connects it. Kind of like what you see here. This looks like these might be a connected one, right? Especially for these problems, you want to draw it out because they're asking where is it continuous and not continuous. So they might have a trick one. Like these are more trick ones where they connect. So, and then when you're drawing your little table to graph it, go ahead and make a note that this particular point right here is going to be a hole in the graph. And then you would go in and draw it. So that point is 2, -4. Let me do this. And this is just kind of an ugly little graph here, isn't it? And that's here. And it's saying less than 2. So it actually points in the direction you're supposed to go, right? But that's going to go like this. So it's just going to go straight through that point. The only ones you have to worry about if there's a hole or not are the boundary points, which are the ones that are given here. Any other like little points like 0, -4, those are just points. They're going to be closed. They're just to help you graph it. They're definitely okay. All right. That's the first piece. How many pieces do I have? 3. So we're going to do the next one now, the one that's valid from 2 to 5. Oops. Are you okay? Okay. I don't think he knows his mic is on. Okay, so we got x and x plus 1. I'm going to do this one in a different color. And this one's going from 2 to 5. Now, is this what is x plus 1? Is that a straight line? Is it a curve? What is that? You're not sure? Yeah, so it's a straight line. So we have a power of 1 on the x. It's going to be a straight line. If you had a power like an x squared, those look like these. This comes like from in business calculus, you went over that a little bit, but you may not have. I mean, not business calculus. You're in business calculus. In business math, like we went over this just now in business math with my students. But if if you didn't spend a lot of time, you might have forgotten. But yeah, so if it has a power of 1, it's just a straight line. Um, so we're going for, that means we only need 2 points. That's why I'm asking that, because then you 2 points define a line. If you have like a power of 2 or 3 or something, you may need more than 2 points to get the shape of the graph. Yeah. And then we want to make a note right here. These both have an equal on them, don't they? Yeah. So does that mean it's included or not included? Yes. So that it's, which is closed, right? So it's closed. And so you can make a little note if you want to of that this is closed. Closed circle. And it's x plus 1. So 2 plus 1, I get 3, don't I? I'm going to do that in black. We'll just write 2 plus 1 here and 5 plus 1. So 2 plus 1, I'm going to get 3. 5 plus 1, I'm going to get 6. So that means on the graph, I've got 2 close points, 2, 3. And let me go up here. 1, 2, 3. And we have one at 5, 6. I'm going to go ahead and just get these little points. Okay. So at 2, 3, and at 5, 6. Okay, so this is going to be like this. So it's filled in. There's no hole right there. Means this one's out, right? And actually, you see how it's open and then closed there? That's this one. It's not this one. But we can go ahead and finish drawing the other part too, just so you can see it. So this last one's also a constant function, like the -4 was. Constant just means it's a flat horizontal. So it's x, and then the y value is 6. I'll just put y here. But it's going to be 6 all the way down, right? And we can pick any x values where x is greater than 5. Now, even though 5 is not included because there's no equal, we still going to put it because it's a boundary point. We just make a little note again that there's it's open or whole, however you want to say it. And then make a little, you know what? Hold on. I'm going to be a little OCD because I think the coloring kind of helps on these problems. Let's do, what color do I want to do? Purple? We'll do purple. Okay, so this one is open. Okay. And that one is here. So when x equals 5, this one is open. There's a hole in the graph then, right? Now the thing is, even though there's a hole, it got filled in over here. It was included on this 5, 6. This is where I'm saying if it's closed, that trumps if there's a hole. Like if one other piece of the thing has it closed, you have to go with that. Okay. And then we can do any point here. I don't know, 7, doesn't matter. But that's going to fill in. And then we have, let's see. It's at 6, right? Let me do one more point here. 5, 6, 7. Purple. That's not very nice. And then it just goes like that. But yeah, so even though that says hole here, this, it trumps that. Okay. So closed since one of them is closed. As long as one of them says it's closed, it's going to be closed, okay? Since one piece says closed. And I'm just putting this because I'm going to post this with a video again, like the last one I did. I'm going to post the PowerPoint, so if those that didn't get to come can look at it. Okay. And I might post the PowerPoint earlier. I don't know, because last time it took me a long time to edit the test or the session because it's an hour long. It takes a long time to load and edit it. Okay. All right. So yeah, that's just a quick rundown of the piecewise ones. And I mean, you can do this on the calculator. I don't know if you want to see that because y'all can use the graphing one. You want to see that? Okay. All right. Not this one. That one doesn't work. I think we had -4, right? And that was when, so we put the portion of the graph we have, and then what we do is we go second math, and that gets you these things. And it was when x is less than, right? So we pick the less than. Oh, I forgot my x. X is here. And then less than. And it was, I believe, 2, wasn't it? Okay. So that's one piece. And you're going to put a plus. The next equation was x plus 1. I'm going to put a parentheses because there's more than one thing. The -4 I didn't have to because there's just one thing. And it was in the front. But x plus 1, and then the restriction was there that, I think it was that 2, if we go to math, less than or equal to x. And you have to do it in separation like this one. And then it had x less than or equal to, I think it was 3, wasn't it? I'll double check it before I hit enter. But that's another piece. And then you go to the second. Okay, I'll show you again in a second. Let me put the thing in there first. Okay, so the next one was, I believe it was 6, right? And that's when x is greater than, let me actually look. I forgot what it said. It was 6 when x is greater than 5. Oh, and that's a 5. That's not a 3. Let me change that. Sorry, let's see. So this is a 5. And it's going to be 6 when x is, and then here's where you go. You go second math. And you can get these. Did you see that? Okay. So then after that, you just hit graph. See? It doesn't show you the hole, but if you don't know where the hole is, like at 2 right there, like, because you're looking at the picture of it, right? And you don't know which one has the hole. On the calculator, what you're going to do is you're going to hit trace, and you're going to hit 2. And notice that it's up there. That means there's a value there. There's no value right here. Okay. And then that's it. Yeah. So this is the only point where we have a discontinuity then. We didn't really answer the question yet, right? But this is the only place where there's it's discontinuous, because if you trace your pencil along, even though there's a value right here, there is a function value, it's still discontinuous because you're having to jump up and go here, aren't you? Yep. But if and you can see the holes filled in on this one. But if you're not sure, hit trace. That was it. 1, 2, 3, 4, 5. Yeah. So we actually have a 5, 6 a value. So that's it's continuous right there because there is a value, but not here. There's a value down here, but then it's nothing. I'm sorry, it's up here, but not down here. That's a jump discontinuity. And that was what was that at? That was at 2. So the graph was, where was the value at? Was it down? I think it was this one, wasn't it? Is that what we picked? Oh no, we picked the second one because there's a value at 5, 6, and there's a 2, 3. Okay, so the second one is the one. And then it says select the value of x for the function is discontinuous. It's just going to be right here at 2. And that's it.